Hey, what's going on, guys? copypaste here. In this video I'd like to introduce a new release of JavaScript chess engine WukongJS I'm currently working on. So here is the version 1.4. Yeah, probably I forgot to update the repo at the moment. Yeah, so it's still like in the alpha stage and the rating was questionable, but now it's really 1720 hundreds. And just to prove that, I already have 100 games match played versus TSCP. So just to give you a very quick idea regarding that. So here in the PGN folder we have this one with the own PST. I'll now quickly cover what exactly has been changed, what kind of new features has been added, but just let's have a look at the results. So yeah, well, it's slightly -7, while TSCP is rated at C0 about, not about, but exactly 1723. Well, I still think that the rating 1720 is quite pretty reasonable here. And again, to bear in mind that this time I'm using my own texel-tuned material weights, game phase scores, and b-square tables. Unfortunately, they are about 100 Elo points weaker compared to values by Ronald Frederick and his rofChade chess engine, and to be honest, my values really suck. But at very least, they have been obtained on my own using my very primitive implementation of texel tuning, so we have what we have. But anyway, it's at very least 100 Elo points stronger compared to the previous version that even did use the Ronald's PST values, p-square table values, because I had horrible bugs in horrible bug in the null move pruning. I'll now just quickly point that out, and yeah, and then we'll go demonstrating some new features. So the main feature from the user perspective, the opening book has been added. But first, I just really want to quickly walk through the source code. So if we just go to the null move pruning, make null move. So here within the take null move, within the null move pruning, I was when I was restoring the value for a hash key, instead of using dot hash, I used .hash key, which is totally wrong and not the name that has actually been pushed within the make null move. So it's called hash, not the hash key. So that's the horrible bug that was really making search again like about 100 Elo points weaker compared to its current state, because yeah, it was completely malforming the hashes, so the hashes were no longer correct after null move pruning being applied, basically. Okay, so regarding the engine itself, I've added the transposition table, so that's also worth of having a quick look at it. So the very first issue we had, well, so by default, yeah, by the way, okay, I just need to make sure that my new value for hash entries, yeah, just realized that I need to update the value for the hash entries. So but the default size of the transposition table is 16 megabytes. I think that's quite enough for browser play, and obviously using the UCI set option command you can manually set whatever hash size you need in margins between 4 megabytes the minimal hash, 128 megabytes the maximal one. Bearing in mind the fact that Node.js is very memory consuming application itself, so even without the hash table it's around, I don't know, maybe 40 megabytes. So it's quite pretty heavy from the memory user's perspective, and I can't yet do anything to that. So I think that 128 megabytes at very most is quite pretty enough here. So another issue in JavaScript that I have no idea like how to get the size of the variable in bytes in JavaScript. It seems like it's kind of impossible, believe it or not. It's very weird, but that's what we have. So again, like the measure I try to apply in order to make the size of the transposition table in WukongJS being equal to the transposition table sizes of other engines was the actual number of hash entries. and the hash entries number was calculated assuming the 32-bit integer by the 32-bit integers storing the values within the hash itself for hash key, depth, flag, score, and the best move. So overall it's 20 bytes, so that was taken to calculate the number of entries. So at very least I can say that the number of entries in WukongJS and say in, I don't know, like in some engine in C that uses the similar hash hash objects, basically they should be about equal in terms of how many actual particular hash entries we have there. Well, from the megabytes perspective, if you just have a look, like with some memory tracking tools, it might be showing total nonsense, because again, like the Node.js itself, plus it's very hard to say like what's the exact size of the numbers in JavaScript. So the number type is, they say like this is 64 it's a 64-bit long, so it's at very least 40, not 20. But anyway, when I tried to make any other value but 20, guys from WukongJS started telling me that that's horribly wrong. So at very least I decided to take this number of hash entries as a measure to measure actually the size of the hash table. But again, like from the user perspective, you still can order this by you can just assign the value in megabytes and you're done basically. So that's kind of it. But just if you just say this set this 4 megabytes, actually it would use probably more than 4 megabytes, but it would be kind of like it would behave as it was 4 megabytes in terms of the number of hash entries that were actually being initialized. Another very interesting hack that, again, a guys from WukongJS in general, and Martin Sedlak, the author of Chan chess engine. So there is a chess engine called Chan. Probably that's not the Chinese word, as you might wonder, but it's short from chess engine basically. So I was doing some weird nonsense in order to obtain the in order to resolve the issue of having the negative hash key, because in JavaScript we don't have the typed data, and there are some tricks and hacks with the so-called typed arrays, but I just didn't really want to involve those. So the idea is to bitwise end the hash key with the 31 bits, with the 31 bits. So the 32nd bit, the negative, the bit that is responsible for telling us whether the number is positive or negative, so that bit is dropped. So we bitwise end the hash key with the rest of 31 bits, with the mask of 31 bits being like equal to 1, basically set up to true. And this is the bit hack to actually convert the negative value, the negative 32-bit value, which our hash key is, to I'm sorry guys, here is a new member of my family, by the way. Yeah, her name is Bai Hua. It's Chinese name for white flower. Sorry for just torturing and climbing me, and she's climbing on me like as if I was a tree or a mountain. I'm sorry for that. Well, anyway, so this is the bit hack to convert the 32-bit integer, the assigned to unsigned, let's say, and then we just using we're moduling this by the number of the hash entries to get the reasonable index to index our hash table. And all the rest of stuff is the most simple possible so-called replace schema for transposition tables. So it's the least efficient of those possible, but the most easy to understand and the most straightforward. So the entire functions that are kind of are responsible for hash are these functions like write hash entry to write hash entry, read hash entry respectively. Init hash table to adjust the size of the hash table itself. So it's literally like to just reinitialize this. It's done every time when a new game is started, and on the on the engine initialization in general. Also, the set hash size literally alters the value of the hash entries, just to make sure that it's kind of like being adjusted properly. Again, I'm sorry for this value. I just really forgot to change this. So I didn't yet publish the release, but by the time when you would be watching this video, the release would already be out there, I hope. Okay, so this is it regarding okay, now my kitten is she's climbing the curtain. Yeah, okay, didn't crash yet, hopefully. So yeah, what else? This is regarding the engines part. So I fixed that horrible bug on restoring the hash during null move pruning, added this hash table, and this hash table with a bug fix of restoring the hash gave me around 100 Elo points compared to the previous version, which had those bugs. But by the way, all the versions since the version 1.0, yeah, they all had that bug with the restoring of the hash key. I fixed this bug in all the versions. So if from now on, if you would be downloading the previous versions of Wukong, you just can be sure that this bug has been fixed in the previous versions as well. And another kind of from the user perspective, another interesting feature and update from the user perspective is adding the opening book. So yeah, so we're done with our results, right? So let's go here, and so now you see like it uses book moves until the book line is finished. I've used my favorite book lines, and almost all the openings are unorthodox, because I really like this hypermodern style, like Kinzindian attack, or this B2B free opening. I don't remember how exactly that is called. And it's randomized as well, so it would be running a new opening every time. So it's kind of like, maybe not every time, but it's quite pretty random still. So obviously you can just, obviously you can just try to play. So you can go for this, go for this. For classical Sicilian, you can go for closed Sicilian, so he knows the both variations. By the way, in classical Sicilian, a very fun thing that I've added my favorite dragon variation here, so it would be plain Sicilian dragon here, as you can already see, which is very nice. I'll probably just miss the move order that I've used in the particular opening book line, but anyway, probably F3 should be played there to keep the yeah. So to keep the book line, F3 was played, then bishop here, knight here, then castling. Yeah, so okay, so this is the position basically. Now, yeah, this is already the very first move by black. So yeah, you're free to change the order of moves to start the H-file attack and things like that. Okay, guys, so this is it basically. And by the way, is gonna put the rook somewhere? Yeah, so it already defends from exchanging the bishop. Well, it's not that smart, but still, it's kind of what it really meant to be here. So, oh yes, after this, so yeah, my attack is no longer working. I believe my attack is no longer working. If I just try to put the rook on H here, if I'm not get mated before, yeah, it's gonna be, well, doesn't matter really. So. Also, just it was set if we force the starting position being initialized by from the Effian string. In this case, it would actually start searching for the moves instead of using the opening book. And this is done in order to just to give you an idea regarding the current particular p-square tables that are working here in the in this newly tuned version of WukongJS. So this is how the self-play at 1 second per move now looks like. So it's quite a bit different, quite different compared to what it was before, basically. Well, maybe not the strongest ever, but yeah, it's the most decent play I've managed to come up with eventually. So this is kind of, so we have 1, 2, 6, 7 pawns, 7 pawns. Yeah, so it's about equal position. Well, it thinks that white is slightly, or no, it's probably black is slightly, or not sure. So if I just make a move, yeah, so white is slightly worse because of blundering the pawn. Shouldn't blunder a pawn, and now blundering the bishop. Yeah, it's even worse. So let's take the bishop. Okay, let's take the bishop first, and yeah, and still the pawn is doomed to be captured, unfortunately. Even if I pin the knight, still losing this one. So it takes, yeah, nothing much really. But anyway, so let's feel free to play chess basically with this app. Okay, so this is it regarding the opening book. So a very quick look at the evaluation weights, the eventual look of those. So have a look that I have asymmetrical values for piece weights, believe it or not. So this seems to be working the best. Quite a fun. And here are the tuned values, the values that are tuned using the mixture of manual tuning and calculating the mean square error, and the automated tuning with the most simple, I guess that's called coordinate descent algorithm. When we just adjusting the every single parameter by 1. Okay, so my little friend Baihua has come back here, guys. Let's see how the cute this kitten is. Yeah. Okay, I really love her. Somebody probably considered Baihua to be garbage and just throw her away, and I found her in the yard near my house. My neighbors are not very kind people, because throwing away kittens most likely. But fortunately she found a new home, and now I have up to 4 cats. I have 3 adult cats and this one little kitten by Hua. Okay, but the name, by the way, a very good name for a chess engine. I mean, like, yeah, by Hua sounds good, isn't it, guys? Let me know what do you think in the commentaries below this video. So yeah, so these are the p-square tables. Feel free to examine them. And again, like as I was already mentioning, they are based on the simplified evaluation by Tomasz Michniewski, but really has been heavily tuned after, and also well, obviously I've added the endgame part here. So the pawn's endgame is completely down from scratch. So these values are duplicating the opening values. The rooks are handcrafted and Texels tuned later. The queen is just so the queen and the king are just copies from the opening. So that's kind of what we have here. Okay, so I think this is kind of almost it, right? So did I actually cover everything I wanted to cover here? Yeah, I think so. So yeah, I'll now just prepare the release, upload all the files, make a new zip file for the latest version, fix the default number of entries within the hash table to make it represent something near something equal to 16 megabytes, at least from the perspective of the number of hash entries, like it happens in other engines. And that's it basically. So yeah, I think that is it. Okay guys, so yeah, as you can probably see that I feel very kind of upset and have a very bad mood because the results of tuning really suck, to be honest. And again, like the rofChade's p-square tables are doing fantastically well, so at very least 100 Elo points stronger compared to this copypaste one. So if you want to have the WukongJS 1.4 100 Elo points stronger compared to the release version, you just feel free to copy paste the p-square tables from version 1.3, and you will have 100 Elo points stronger chess engine that would be crushing TSCP. So that's basically kind of it. Okay, so but anyway, I still want to keep my own values, despite the fact they suck. Still, I just want to make I just want to keep my very own values. Also, yeah, probably the very last word before I end this up is, at this moment I feel like I've reached my limits. So, well, to be honest, yeah, my level of dumbness is kind of exhausted. So I just don't even know what else can I do to improve this chess engine. Well, obviously there are always lots of ideas, like starting from making the mode generator faster, which actually can make it search a little bit deeper, hence being a little bit stronger. But anyway, so at this point, a noob's engine is probably at its state where it should be. I really hope to have a 2000 engine in JavaScript, but that's kind of too much, really. So if it would have around 1720 in CCRL, I would be extremely happy with that result. And I think that now I'm already in the state where I'm ready to send this engine to Gaber Satz, the member of CCRL group, the tester. So hope he would take WukongJS to run in the tournaments versus other engines, just to make sure that it would be having an official CCRL computer chess writing list right in here. Okay, guys, so this is it from my side. Hope to come back to you soon, and I really hope that this automated evaluation, the very last nail in the coffin of the evaluation function, wouldn't be depressing me too long. I really hope maybe, I don't know, maybe some miracle would come up and I would be a little bit smarter to actually trying to get some better results. But what is killing me the most is the fact that if I calculate a mean square error based on literally whatever data set I tried the GM 2600 PGN position from that PGN, I tried positions from self-played PGN, but every time I'm calculating the mean square error, no matter how many positions I have, not only like 1,000 or 10,000 or 30,000, even with a 100,000 position, the result is always the same. The mean square error for rofChade's tables is greater than the mean square error for Wukong's p-square tables. So from the statistical perspective, Wukong seems to be kind of better because the error is less compared to rofChade's, but from the actual plain strength perspective, that's kind of total nonsense. So I'm very confused with this point. Well, probably the way of how I generate the data set is the core issue here. And I've been heavily discussing the way, my particular way of generating the data set on TalkChess, and some of the guys there told me that at very least it's very good that I'm not just blindly generating this data set, but I have some ideas in mind to follow in order to generate it, and it's generally very good to follow some ideas rather than just randomly trying some stuff via the trial and error method. So, but anyway, despite the fact that I had some ideas regarding the linear separable data and trying to linearize the nonlinear processes that happens within the chess game, and trying to as far as we're using this logistic regression, which is the binary outcome predictor in essence, that case just kind of like seems making big sense just to trying to provide the linear separable data, and that's the way why I was dropping all the tactical positions and picking up only those positions where the evaluation, where the static evaluation exactly equals the output of the question search. And even despite the fact that after tuning the values, the quest and search values might have been changed, while the evaluation would still be the same. Well, I mean, not the same, but so just okay, forget that. So I kind of try the most linear way possible there, but still the way I did actually shows totally confusing results, because rofChade's p-square tables are much around 100 Elo points stronger compared to Wukong's one, but it has a greater mean square error, significantly greater in terms of mean square error, basically. So that was like 0.13 and 0. Well, I don't even remember that, guys. Maybe I've stored that somewhere. Maybe I've stored that. I tried different. Yeah. So this is one. Yeah. This is one of those. So I have in Wukong 1368 and in rofChade 1364. But despite the fact the mean square error in Wukong is less, still rofChade is much stronger. Okay, guys. So again, like for a noob like me, having even having this sort of a result is already not that bad. So I really think and hope that you would be able to come up with a much stronger JS engine that I do. This is it from my side. Hope to see you in the next videos. Until that time, and take care.